The large language models, or LLMs, have sparked a revolution across various industries. These advanced AI models possess a unique ability to comprehend and possess human-like intelligence. Trained on vast amounts of data, they can perform tasks ranging from language translation to complex problem-solving. Now, their impact extends to the semiconductor industry. To understand this, let us look at semiconductor product development. Designing and manufacturing these tiny devices is incredibly complex and requires precise engineering. Semiconductor design involves creating detailed blueprints. This process includes steps like logic design, verification, and layout. On the manufacturing side, we have multiple processes that require precise control to achieve high yields and functionality. Let us now explore how LLMs are revolutionizing these processes. In the design phase, LLMs are proving to be invaluable tools. They can automate critical aspects of the design process, such as generating RTL code from high-level specifications, optimizing designs, and verifying correctness. It saves time and allows engineers to focus on innovation rather than repetitive tasks. For instance, an LLM can reduce the time needed for design synthesis by up to 40%, leading to a faster time to market for new semiconductor products. In the manufacturing phase, LLMs play a crucial role in predictive maintenance. By analyzing data from equipment, they can predict potential failures with an accuracy of over 90%, enabling proactive maintenance and minimizing downtime. When it comes to defect detection, LLMs are proving to be game changers. By combining them with computer vision, wafer inspection can be enhanced to a new level of accuracy. Traditional inspection methods often miss subtle defects or generate false positives. However, LLM-enhanced systems can increase defect detection accuracy by 30%, ensuring higher quality and yield. LLMs also help optimize manufacturing parameters by analyzing vast amounts of data. For example, optimizing the etching process parameters using an LLM can result in a 15% improvement in etch uniformity, directly impacting the commission and yield of the semiconductor devices. Many fabs have leveraged these models to enhance advanced processes, achieving better performance and power efficiency. In supply chain management, LLMs improve demand forecasting and inventory management. Analyzing market trends and historical sales data ensures that semiconductor companies can meet market demands efficiently. Lastly, LLMs automate the generation of documentation and compliance reports. This saves engineers time and ensures consistency and accuracy. An LLM can generate comprehensive documentation for new semiconductor designs in a fraction of the time it would take manually, ensuring all necessary information is included and up to date. This is particularly beneficial in meeting regulatory requirements and providing detailed product information to customers. To summarize, from design automation and predictive maintenance to defect detection and process optimization, LLMs have started to transform semiconductor design and manufacturing. They make processes more efficient and accurate, driving innovation in the industry. As LLM technology advances, the influence on the semiconductor industry will only grow, paving the way for more innovations and breakthroughs in electronics.